Hello, we're presenting the paper The Hyphae House and the Paperless Worksite. We speculate on collaboration methods between machines and humans on the construction site and discuss the potential limitations encountered in the design and construction of a one-to-one scale prototype named the Hyphae House, which was built without printed construction drawings. These drawings were replaced with AR, augmented reality, via smartphones. Form-wise, the focus is on the structure and growth process of the mushroom, particularly its hyphae, in the broad context of the minimal essential house. An AR exhibit was also designed to extend the didactic and hyper-reality nature of the experiment. This research was done during a postgraduate degree program in design technology that focused on contemporary technologies in architecture and design, biomimicry, parametric modeling, and AR tools that culminated in the set prototype. We worked with three design constraints. The first was to use an affordable, locally produced material consisting of a standard hollow concrete block. The second was to employ an aggregate as the only extra resource other than the blocks themselves. And the third was to refine design and build a prototype in 5 days. So the building material was a hollow concrete block measuring 29 by 19 by 14 centimeters, produced by a local partner company, and a biomass ready-to-use mortar. The overall intention behind this choice was to use an accessible, simple product to generate complex geometries, expanding the technique of standard parallel stacking. Various tools and media were used throughout the process, including mock-ups in multiple scales, 3D prints, parametric models, sketches, renderings, and various visualizations of the proposals in one-to-one scale in AR.
The source of inspiration is the hyphae, or branched filamentous structure, characterized by long cylindrical fungal cells with multiple nuclei. Pre-existing reference projects are the walls of the Gantenbein vineyards, built by robotic arm by Gramachan Köhler in 2006, or the Koblogor project, where concrete blocks were located at specific angles according to CNC milled and laser-cutted templates by Subdivi Architecture in São Paulo in 2013.
No digital fabrication machinery or technical drawings was used in the process, and the main challenge was to test the feasibility of AR with smartphones to design and construct the prototype. AR proved to be a powerful didactic tool, especially during the COVID pandemic, since most students already owned the necessary hardware, in other words, a computer and smartphones. Cement blocks are generally used orthogonally due to low cost and construction agility, with technical drawings usually describing the position of the blocks without incorporating non-orthogonal angles, which would possibly, at least that's what's argued, it would lead to inaccuracy and higher labor costs. But based on precedents, we know that digital manufacturing technologies have expedited construction of designs where each component is positioned at a different angle. But digital machinery still remains away from the vast majority of construction sites. So in our case, we decided to use smartphones because it's a widely available tool in construction sites, but not yet used for directly in construction. So we would depend upon training the workers, in that case, the students.
So, a 7 meter by 12 meters grid was deployed over the construction site, then populated with QR codes placed every 1 meter, which were used for referencing the location of smartphones in the physical space. The geometry of the prototype was further developed and adapted to the site with the support of Rhino and Grasshopper. Pairs of students with smartphones running the Follogram app place each block on the worksite, with smartphones demonstrating the relevant information for the row being constructed. These pairs of workers were alternated without detriment to understanding and continuity in fabrication. Due to some inaccuracies regarding the location marks pointed out through smartphones, after a few minutes of use, as discrepancies between the digital model and the physical prototype were observed, the position of the device via QR codes had to be re-referenced. To facilitate the understanding of the overlay of the blocks on the digital model, we isolated only the most relevant information to be displayed for each pair of builders. The geometry was represented in translucent blue, which allowed the physical block to be seen. Used as a reference for positioning the blocks, the perimeter of its top face was indicated in red. The perimeter of the intersection between the blocks on each row was represented in green, facilitating the visualization of the location of the aggregate.
As for results, result number 1 pointed out that our experiment by using AR in the building phase turned out to be feasible without the use of construction drawings. We also should point that given the current stage of smartphone self-referencing technology, our experiment confirmed a tolerance of precision in the range of 0.1 to 3 centimeters in the location of the blocks. We should also say that the construction took 2 afternoons with pairs of workers working simultaneously, and we estimate that this was about 4 times faster than regular construction, which would require transferring out the drawings to the site first and then actually building the object. Result number 4, we should say that the use of the ready-to-use biomass mortar product really expedited the process of construction. We should also point that some factors like sunstroke and visual pollution sometimes compromise the access to the visualization of AR exhibition, and that when users moved away from reference images, there were also some registration failures.
We would like to conclude pointing that this prototype demonstrates that AR challenged one of the architect's most common tasks, the production of printed construction drawings. With the advent of smartphones, we have become accustomed to having computers in our pockets all day long. As Colomina and Mark Wigley says, there are more active cell phones on the planet than people. By relying on this condition, we identified 2 major advances. Computers are coming out of our pockets and into our heads ever so smoothly. And we can interact with such devices through gestures that define what we are seeing, allowing a new wave of professions to be transformed. Finally, we would like to point that we see the possibility of visualizing information at the construction site from several layers of the 3D model in a specific site and in a one-to-one scale, facilitating the understanding of the project by its several actors without the need to interface with physical drawings.